Okay, so we're going to work on solving polynomial inequalities, and in order to get where we need to go with this, we're going to try to factor this polynomial here. Now the first step, and the easiest thing, would be to actually common factor our value of 2 out. Since all of these are even numbers, we're going to take out a value of 2, and specifically maybe even -2, just so when we do go to the factoring everything, we're working with our positive values. So when we go to factor this out, the idea is that we're going to divide each of these values by -2. So our -2 becomes outside of the brackets, and we're left with positive x cubed plus 3x minus 6x minus 8. Okay. From there, we're going to look at our bracket specifically. So when trying to find a factor, one of the ways that's very helpful is looking for factors of the last term to see if any of those create a 0 within these. Okay, so we might have to try it out. My calculator on here is not so great, so maybe we'll get you a calculator on the side. And we're going to try some factors of this value. Quickly, 1. Oh, and that should be squared. Don't forget to put a square in there. Okay, 1 will give us, no, not a high enough number. So let's try with 2. 2 will give us 8, 4. Yes, 2 will work great. So if you put it in, I'll quickly do it on the side. Thanks, Steph. We'll get 2 cubed plus 3 squared. I'm kind of running out of room. And then minus 8. 2 cubed becomes 8. So we have positive 8 and -8. So they will cancel each other out. So we're then left with 3 times 4 minus 6 times 2, which both create 12s. So they cancel out. So 2 is a factor of this. So whether we're going to solve it synthetically or through long division, we'll probably use synthetic division. I'm going to show you the other way, actually, that we go about doing this. For this synthetic division, I'm actually going to use addition when going down. Okay, and the reason I'm going to do addition is I'm actually going to use the x-intercept of 2. So instead of using, because this is 2, normally we would write it as x minus 2 if we're going to do our long division. But because that means x is equal to 2, I'm going to take the value of 2 and then put our polynomials here. So we have 1, 3, -6, and -8. So we bring down our first term, which is 1, and then we need to multiply it by our value here. So we multiply by 2, and we end up with 2. So we're going to add these now. So 3 plus 2 gives us 5. Multiply by 2 again, we end up with 10. -6 plus 10 will give us our 4, and 4 times 2 gives us 8, which gives our remainder of 0. Okay, so when we factor this all out, and is that okay, the addition? That makes sense? Okay. So when we go to factor this all out, we still have our inequality. 0 is greater than and equal to. X minus 2 is kind of one of our brackets. And on our polynomial, we're left with x squared plus 5x plus 4. Now this one is a quadratic. So we can actually use, and because it has a value of 1 here, we can use some very simple factoring. We need 2 numbers that add to 5 and multiply to positive 4, which are actually 4 and 1. Okay. Are you okay with quadratic factoring? Okay. So we'll kind of go through this the fast way then, which means that these are going to work out into factors of x plus 4 and x plus 1. Okay. So we've now factored this. Now, sorry, I forgot to write this in. We still have the factor of -2 here. So we have our -2 factor, and this value is actually important here because we need values, and we're going to split this up just like if we were finding x-intercepts. We're going to split this, and in this case, we're going to split it into 3 separate equations here. Okay, and we need to find values that will essentially give us values that are less than 0 when we go to plug them in. Okay, so we're going to set this up, and I'm going to attach this -2 to one of the factors. Okay, technically it doesn't matter which of the factors we attach to, so I'm going to attach it to this factor because it is technically part of this. So we have 0 is greater than or equal to -2 x minus 2. We have 0 is greater than or equal to x plus 4. And 0 is greater than or equal to, I'm going to get her. So we said we split all 3 of these together, or not together, but we split them all. And now this 2 is actually going to be part of this. So what we're going to do is we're going to use different cases. So we have to do a lot of mental processing at this point. We know that the original question is asking, when is x greater than and equal to 0? Well, since these are specifically factors, right? We know these specific points right here are factors. We can kind of deduce what the zeros are going to be, but we're going to try to solve it algebraically using these inequalities. So what we've done is we've broken it into 1, 2, 3. So we're going to name them A, B, and C. Okay. So this pairing here is known as A. This pairing here is known as B. This pairing here is known as C. And if you want to split the -2 into another one, you could have called it A, B, C, D. It doesn't really matter. We've just attached it here. We're going to get values that are less than and equal to 0 when A is negative, B is negative, and C is negative, because we're multiplying all these together, right? This is the idea. We're multiplying these together. So we'll get something like this when we have a negative times a negative times a negative. We'll also get this, and we'll call this case 1. We'll also get this when one of them's negative and two are positive. So there's many different cases of that. For instance, when this is negative and these two are positive. We'll get it when this is positive, the negative is in the middle, and the last is positive. We're just essentially exhausting the options, right? And then when these two are positive. All of these will lead to values when we have 0 or that are less than and equal to 0. So what we're going to do is we're going to take A, B, and C and build them into inequalities to see if we get common answers on number lines. So what we mean by that, case 1 we'll call here. So this is our first one. Our A was, I gotta make sure, -2x. There you go. Negative 2 times x minus 2. And it needed to be negative. So it has to be less than 0 in this case, okay? And I guess technically we could use our equal to too, because we know that that's going to be a coordinate right on it, right? This one here has to be a negative, so it has to be less than 0. So we're looking at x plus 4 when it's less than equal to 0. And, excuse me, finally, x plus 1 when it's less than and equal to 0. And that's for case 1 when they're all three are negative. And that's how we set up the inequalities. So this is less than 0, less than 0, less than 0. Essentially, they're all negative. And we solve for them. So we're dividing by a negative value here. So that flips this inequality around. We have x minus 2. So when x is greater than or equal to the value of 2. When x is less than and equal to -4. And when x is less than and equal to -1. So we draw these on number lines. Okay. So we'll draw 3 different number lines, and I guess we'll stack them on top of each other. 1, 2, 3. Okay. We have when x is greater than and equal to 2. Okay, so when we have the value of 2, we're going along here. We have when x is less than and equal to -4, and I should actually set these number lines up properly, sorry, so that we can see the visual. The idea is the visual here. So our important values being 2, -4, and -1 in this case, okay? And our second one, it's when when we're less than -4, so it's way over here. And here when we're less than -1, okay? Unfortunately, we don't have a spot where all 3 lines are in common. These two are in common after -4, but this one isn't. So there's no solution to the first one. This didn't help us. It didn't help give us an answer. So we go through the second method here. So we try case 2. And we continue this process over and over again. So we'll try to go through it a little quicker this time. In this one, we want only this one to be negative and the other two to be positive. So when we set up the inequality, we have, we'll call it case 2. -2, x minus 2 is negative, right? So less than 0. And in the other two cases, I just got to remember what they are, x plus 4. They're greater than 0. They both have to be positive. And I think it's x plus 1. So we solve for them. Flips the inequality. Essentially, the idea is this becomes +2. This is -4. And this is -1. So, again, our number lines to see if we have anything in common. So we set up our 3 number lines. Again, the values are always the same because those are intercepts, right? We have at 2. So we're greater than and equal to 2. When we're greater than and equal to -4, okay, that's good. We have another set in common. And when we're greater than and equal to -1, great. So at the point of 2, everything is in common. So this is a solution. One of the solutions is when x is greater than and equal to 2.
Mm-hmm.
Okay? We've got to test the other two cases. Case 3, bit redundant, isn't it? But the first one is positive, so we go negative 2, x minus 2 greater than 0. The second one will be negative, x plus 4 is less than 0 and equal to, and finally greater than 0. This flips, x is 2, x is negative 4, and x is negative 1. Okay. Did you follow what I did there? Okay. Same idea. Let's quickly set up our number line, because I know this process is redundant. It does seem to be a bit faster when we do intervals, right? Okay, the idea when we're greater than 2, okay, so we know that. When we're less than negative 4, it doesn't look like we're going to get one. And when we're, sorry, what is that? Greater than negative 1, right? This is nice that they're in common, they're not, no solution. So case 4 is our last one. Will there be a different solution for case 4? That's when the last one is negative and the other two are positive. So negative 2, x minus 2 greater than 0, x plus 4 greater than 0. Both of these are positive. And when x plus 1 is less than 0. Inequality flips. X greater than or equal to negative 4, and x is less than or equal to negative 1. Last number line. Wonderful. So we set these ideas up. A value of 2 again. This time when it's less than 2, right? So anything to the left of 2. Anything greater than negative 4. Okay, anything greater than negative 4. And anything less than negative 1. And this is, and essentially I'm putting them in the respective places along the number line. Anything less than negative 1. Okay, well in this one we actually have a very nice in common from negative 1 to negative 4. Okay, remember that one's there.
Right.
All three are in common. So what that's saying is when x is less than and equal to negative 1 and greater than and equal to negative 4, which is essentially our answers in the other one. So those are our answers to this question. This answer here from case 4 and in case 2 when x is greater than 2. Those are the answers to the inequality.